So welcome to Chatterjee Academy. Today's session is a very short session on vector. So those who are starting the vector of class 11 or class 10 in foundation. So two things very important. One is the dot product and another is the cross product, right? So these are the two vector products. Like inputs are the vector. Two vectors or maybe three vector, right? So two vectors is in product producing a new vectors. So the new vector that may be vector, that may be scalar. If two vector is producing a new vector, so that's an cross product. The output of two vector is in vector, and the output of two vector when it is becoming a scalar, that's called dot product, like dot ball. You know the dot ball in cricket, we are not getting run. So similarly, the dot product means two vectors producing a scalar quantity. Example is work done. The work done, work is the the dot product of force and displacement. Earlier you have studied that work is the force into displacement. Now in class 11 or class 10, the advanced studies, you will understand that work done is equal to force F vector dot the displacement vector. So the dot product of these two is producing Fs cos theta. Fs cos theta. So theta is the angle between the two vectors, right? So if you see here, theta is the angle between the two vectors. This is F vector and this is S vector. Now what actually it means? Like Fs cos theta means you can say like the projection of force vector in the direction of the S vector is F cos theta. So F cos theta multiplied with displacement is Fs cos theta. Or you can say the projection of the S vector toward the F toward the force. In both cases it will come Fs cos theta dot product without any direction, a scalar product. So work is in scalar quantity. Now let's come to the bit more fundamental. Like if A is a vector, it's having two components, x component and y component. So it's called the component or resolution vector, right? Under the resolution vector, this vector having two components along x axis, along y axis. Okay, so this is called a two-dimension vector. And one more thing, we have the three-dimension vector. So this is about the two-dimension vector having the x-axis component and the y component, right? So if this is theta, if a vector is making an angle theta with the x-axis, then a cos theta is the x component and a sin theta is the y component. And one more thing is that surprisingly, they are not interfering each others. A cos theta and A sin theta, they are independent two vectors, component, they are not interfering. Okay, let me tell you one real example, that's the projectile motion. In projectile motion, what happened? One is vertical motion, another is the horizontal motion. Whenever we are throwing something like this with velocity u, right? We are throwing something with velocity u and angle theta, making an angle theta with the ground. What happened? This u vector having two components. One is u cos theta, other one is the u sin theta. So u cos theta is managing the horizontal motion, right? And u sin theta is managing the vertical motion. So in projectile motion, we are having two kind of calculation. One is the vertical calculation. In the vertical motion, there is an interference of acceleration due to gravity, right? So due to that reason, there will be max height, and again it will come down. And at the same time, it will cover the horizontal distance. That's why whenever in cricket someone is hitting the ball, so whenever the fielder is trying to take the catch, what happens? They have to calculate both the vertical height of the ball and also the horizontal projection. Like it is in pickup, right? Ball is lift up, but it will come down in ground in a positions. So player have to calculate its horizontal position also by looking the ball, right? So that's a part of the the projectile motions, right? So I think this will help you. And next is the cross product. So cross product, what happened? Like tau, torque is the moment of the force, is the product of the r vector and the f. R is the displacement, the distance vector. Like here distance means what happened? Whenever we are, like, let's say we're opening a door, this R is the distance between the point of application of force and the hinge. If my hand is rotating like this, what happens? Let's say this one. So this is in hinge position, and if I am applying force at this position, okay, so this distance will be the R along a direction. So this is the R vector and the force vector. So R cross F, that is the RF sine theta along a new vector direction. So this is the torque is an vector product, like a vector product, and it's having a direction, it's an axial vector. Okay, so there are so many, the vectors in the cross products, we are getting the vector products, right? So these are very, fundamental things. So I believe that this will really help you. You will think like that. In class 10, you learned that, moment of force is the force into displacement in class 8. Now in class 10, you learn that, the torque is the force into displacement. Even in class 10 also, you are not adapting the vector, you are adapting in class 11. But sitting in class 10, if you know the knowledge, it will really helpful that, the torque is the cross product of R and the F vector, and it is an vector quantity. Right? Okay. Now, what is the unit of the torque? Torque is the force into distance, like, Newton meter in SI, and CGS, it will be the dyne centimeter. Right? So, this is about the very basic on the vector, and for theta, you have a you should have a trigonometrical concept that will really help you, like, the value of cos theta. Cos 90 is 0, cos 180 degree is the, the -1. Then for this part, where you will get the complete knowledge on the angle theta, for that, if there is a chapter in trigonometry, class 11, right? So there you will get the details, like, if this is the first quadrant, second quadrant, third quadrant, and fourth quadrant. I hope you can able to follow me. So let's say this vector is having the angle theta. So here theta is 0 degree, okay, and here theta is 90 degree, here it is 180 degree, and this is 270 degree, and this is again 360 degree. So in first quadrant, all function are the trigonometric function of the positive, like sine, cos, tan, theta, all are positive. In the second quadrant, all sine functions are positive in second. So let's an example, sine of 120 degree. This will be a positive value in the second quadrant, but cos of 120 degree, it will be a negative value. So cos theta, cos 90 is, cos 90 degree is equal to 0. Okay, cos 180 is equal to -1, because in the second quadrant cos theta is minus. So these things, you to get the more confidence, just adapt with these wheels, okay, trigonometric wheels, so that it will also help you in the physics, right? So this is a part of foundation learning, and it's not like foundation for any board, like, ICSE, CBSE, and other board. You should have this knowledge, like, the angle of theta, the functions like sine, where it is positive, sine is positive first and second quadrant, and sine is negative in second and third quadrant. You know why? Because sine theta means perpendicular by hypotenuse. So perpendicular, if you take the y-axis, so y-axis is positive in this range. So sine theta is positive 0 to 180. Now y is negative from 180 to 360. So sine means, y-axis, the perpendicular by the hypotenuse, right? So sine will be negative here. Similarly, cos is positive in this and this, because, cos means the base by hypotenuse. If you take the x-axis as a base, so cos theta will be positive here. So this is the funda you can use, right, to take the things on confidence, right? Okay, thank you. Just follow my session. Thanks for watching the session, and welcome to Chatterjee Academy. Please reach me for any of the doubts, and you can follow our session. Lots of free sessions on behalf of Chatterjee Academy. Okay, bye bye.